This problem starts out by telling you what the initial speed upward of this stone is. Let's call that V naught. It's given in the problem. And it tells you the height of the cliff. Well, let's say that the height of the cliff here that they give you is Y naught. And then we're going to have Y equals 0 on the ground. So because we set Y equals 0 on the ground, that means the positive direction is up. And so that means G needs to be negative 9.8. The first question they ask you in part A is, what is the time when the stone hits the ground? Well, the only equations that we have with time in it are V equals V naught plus GT. And we can't use that one because we don't have V. They didn't tell us anything about V, so we can't use that equation. So that means we're stuck with Y equals Y naught plus V naught T plus 1/2 GT squared. Now, unfortunately, this one is quadratic in time. See, time is here as time squared, and here it is as regular time, and this term is not going to be 0 because we have a V naught. So that means we have to do the whole quadratic equation thing. We know that Y equals 0, so we're going to put 0 here. And then we're going to plug in the numbers that they gave. So you're going to plug in this number, Y naught, and you're going to say plus, plug in the V naught number, make it positive, T, plus 1/2 of minus 9.8 T squared. And now you're going to go into your calculator in the polynomial root finder function and calculate that, or you just use a quadratic formula. Then we go on to part B. This one, they want to know what its speed is just before hitting. Well, now we can use that equation I wanted to use before, because what they're asking you for now is this V right here. And we know the V naught, that was given in the problem, and we know the time, that was the answer to part A. So that's going to be pretty easy. Now, part C is a little more complicated, because now they want to know the total distance. And the total distance is going to be this upward distance here plus this downward distance here plus the whole rest of the way down. Whoops, which I just drew diagonally, but you know what I mean. Okay, this distance here we already know. So the blue distance is Y naught. The red and the green distances are equal. So if we can find the red one, and we can just multiply by 2. So this part here, let's call this distance there, the red distance, let's call that H. So the total distance is the red H plus the green H, which is the same amount, right? So we don't have to calculate that separately, plus Y naught that we already know. So all we essentially need to do is to find H to be able to finish this. So let's have a look at this on the way up thing. For on the way up, we have V naught, and we know the V at the very top there because the V at the top has to be equal to 0. We know V naught, that's given in the problem, so we can use this equation. V squared is equal to V naught squared plus 2G Y minus Y naught. This time I'm going to redefine Y naught as 0, and then we're going to say Y is the one at the top. So we're going to say right here that Y naught is equal to 0, and up here Y is equal to H. So I have this guy is 0, this guy is 0, and this guy's H. So I have 0 is equal to V naught squared plus 2GH. And I can solve for H. Now what I also did was I turned the problem upside down, so G is no longer negative, by the way. So V naught squared over 2G, I find H, and I get 2 of those, add them together, and add on Y naught, and I have the answer to part C.